Good evening, everybody.
Good evening.
Last time you missed, no?
Yeah, yes.
Okay, Balakrishna Yadav. Good evening.
Yes, I'm here.
Yeah. You are coming first time?
So I was in last lecture.
It is not a lecture, it is just a discussion.
Yes, sir.
Whatever we are know about our profession, just we are discussing and we are sharing our knowledge on that one. You have any issues to discuss?
Actually, last time I didn't able to introduce myself. I'm introducing myself right now.
Okay.
My name is Balakrishna Yadav. Actually, I recently started my career in this department, static equipment design engineer. I may be having 1.4 years of experience. That includes 3 months of internship also there. But I have some doubts. It's like I don't know how to use the software PV Lite actually. Till right now, I'm reviewing most of the vendor drawings. So I don't know how it is really equipment design engineers happen on that stuff.
So you are just started your career and you have 1.5 years of experience and you want to know how to use PVLite and that one, right?
Yes, sir. And is it compulsory to do calculation and everything? And for doing calculation, we have to do manually, or is it any another way?
Okay, Ramakrishna, you want to answer?
So are you reviewing the drawings?
Yes, sir. I reviewed mostly vessels, exchangers. Then I even in exchanger I reviewed the condenser drawings. Then I also reviewed the column drawings. And then I also reviewed the platform detail drawings they give the vendors. I also reviewed that all drawings.
So you're reviewing drawings but not the calculations?
Yes, I didn't did that. Mostly calculation I never did.
Basically, you need to learn first of all, you should know what is the purpose of vessel design.
Yes, sir.
Why we need to design a vessel? You know that?
Yes, sir. The basic purpose is to do the processing. Means we got certain requirement of designing a refineries or plant, something like that. They give us a temperature. Means the process department give us a PDS. That PDS has mentioned temperature, design temperature, then materials, then all basic conditions, temperature, pressure, length, and idea of the equipment. And I know the basic formula for calculating the thickness from magazine.
Yeah, Balakrishna, actually Ramakrishna is asking why we are designing the equipment. Actually, when we design the equipment, by taking this all process parameter, we are keeping that whatever we design we are doing to be safe in the operation. For that one, we are designing the equipment.
Yes, sir.
So whatever the process gives the input to you, accordingly you have to make sure that this your vessel or equipment, whatever you are designing, it should withstand with that conditions and requirements. For that one we are designing.
Balakrishna, so the process design, they will do the sizing of the vessel. How much dia, how much length, what should be the process parameter, what should be the design conditions, such like that they will specify based on, they will decide based on their process requirement, they will give you the size. So that is process design. But as far as we are concerned, we have to do the mechanical design of the vessel. So as Ravi told, so we need to check the structural integrity of the vessels, pressure vessels or heat exchanger or any similar equipment for the given loadings. So what are those loadings like? Typically design pressure, your internal design pressure, internal external design pressure, and maybe sometimes wind loads, seismic loads, things like that, and many other kind of loads. So for all these things, we need to make sure that what the material selected and the thickness is adequate. So that is the purpose of the mechanical design. So, and for that you need to generally we are using ASME code, so Section 8 Division 1 or Division 2. So I don't know which design code you are seeing. So I suggest you start read the code and understand, and also see in the drawing that design parameters, design data they will give. You see that, and with that you first understand the terms. What is design pressure? What is design temperature? What is external design pressure, external temperature, and what is MDMT? What is impact test? What is PWST? Things like that. So you can start. I mean, you better go by one. So like that. First, I think I suggest you try to do the manual calculation. How to do a shell thickness for internal pressure, how to do a shell thickness for external pressure. That you go slow. I mean, you want to go to the software, that is fine. But I suggest you that you do it manually. Then you will understand more. You will get more questions, and then you can ask in the group, things like that. Yeah.
Yeah, Balakrishna, one more thing, that you don't know the this operating of PVI light. That's okay, not an issue, because you are just started, and slowly, as Ramakrishna told, that slowly you learn the calculation manually. So whatever there in the PVI light, that's same. Just what inputs need to be in calculation, what we'll do, that is put in the PVI light, that inputs, and it gives the output. Whatever the manual what we do. So PVLite it's just commands with the internal. They made some formulas and that one. So accordingly it gives the values output. So start initially, as Ramkesh told, that just start with manually, and side by side you can take some of the calculation report and that one, and you just check manually you are doing is correct, and what is the output coming from PVLite also you are matching with your manual calculation. Just match with that. And also, if you want to learn some PVLite software, there are some many courses are available online. Like recently, I think Atul Sharma has completed one course with, right, Atul Sharma?
Yes, yes.
So you can take his guidance. So he's telling that whatever where he
Sure.
took the course, it's
Sure. I will.
Yes.
I will. Day to day, I will. Yes.
Yeah. So you can learn that course also. There are many online, they provide the courses you can learn, and simultaneously you can do the manual also. Okay.
Yes, sir. I will try, sir. And can you suggest me, means how can I start with manual calculation?
As Ramakrishna told us, first you take that code, and with code and one calculation report of PVLite. So in PVLite, what your report comes, just try by using manually. Their formulas also given in PVLite report. Their result also given, and input also given. So by that one you try by manually, and there they mention the clause also, which clause by referring what formula they used. By using that one you can just try manually, and the results if come same, then you are doing the right way. If results comes wrong, then you are doing somewhere mistakes in that your manual calculation.
Okay, yes, sir.
Okay.
Yeah, also you can refer plenty of videos available in YouTube, so you can see that also.
Okay, yes, sir.
Yeah.
Okay. Any more questions you have?
Not right now, sir, but if I have any question, I will ask you.
Okay.
Yeah, when you start reading the code, you will have more questions.
Yeah, you are doing when manual calculation, you will find the more how it's coming in that one, and clause and that one, how it's matching, and that you will come more questions. So start doing, so you'll get more questions.
Yes, sir.
Okay. Abhishek Nag, you want to ask something?
Yes, good evening, everyone.
Yeah, good evening.
My question is that regarding the heat exchanger, tube sheet thickness calculation, I want to know what are the factors considered for the design or for calculation of thickness of the tube sheet.
Anybody want to answer?
Yeah, first of all, you should know what is your well side design pressure and what is your tube side design pressure, and of course, and if there is a vacuum, yes or no, those things, and then whether you could design for a differential pressure or you need to design like considering the load cases given in the USX. So things like this, and you should know of course, the type of tube sheet, configuration of the tube sheet. No, of course, you should have the.
Okay. So when we design like shell or dish, so there we have in the formula we have uh, joint efficiency, allowable stress of the material, okay, design pressure,
Yeah.
temperature. Okay, those things we take into consideration while calculating thickness of shell or addition.
Yeah.
So I understand same thing would be applicable for the tube sheet case also. Only the thing is that there we have two types of pressure. One is from the shell side, other is from the tube side.
Yes.
So there are two pressures as well as two temperatures also.
Yes.
Rest of the things like allowable stress of the material, then joint efficiency,
Yeah.
that would be common what we are taking in shell case.
Yeah. Yeah. But tube sheet calculation is not simple. It is very complex.
So we have to perform only by software only by PV light.
No, it's not like that. I used to perform in my beginning days in Excel sheet only. So I used to make 7 Excel sheets. Actually it will come 14 if it is a vacuum. So in our case we didn't have vacuum, so seven cases will come. If there is no vacuum, if vacuum, then you have to perform 14 cases, things like that.
So I think those were the older days when we used to do with the Excel sheet. But now since we have the PV light now, so I think we have to just put the values.
Yes.
And we'll get the thickness.
Yeah, I think if the software is available, I think that's the best thing to do. Yes.
Okay.
Okay,
Now,
Abhishek.
yeah.
Yeah, Atul, you want to say something?
Yeah. The other question is regarding this welding. How do we calculate the fillet size or leg size? Okay. When we mention the drawing, the fillet size is 6 mm or 10 mm. What factors are considered to arrive that value?
Fillet of what?
Suppose it's a nozzle to shell. Okay. So in the drawing we mentioned what should be the fillet size.
Yeah,
so
that.
How do we calculate?
Yeah, that you can see UW section in ASME. So they'll give the guidance how to do it.
Because what I have seen in the PV light, it gives the direct value and some factor it takes into account. But how does that factor comes and that I am not able to get. Is there any somebody to calculate the thickness or to define the fillet size?
Yeah, I don't remember, but the code gives correctly. You can read UW section, UW 13 and 16. Don't remember. You can follow that. Yeah.
Okay. I'll let me check that.
Yeah.
Thank you.
Okay. As first, your question is tube sheet thickness. That tube sheet thickness by PVA light, what are the inputs are there? Just you put in that one, you will get the output from there. And the second one is this thickness of fillet. Normally, thickness of fillet, we used to take 0.7 of that, whatever the thickness where we are welding that one, minimum of whichever thickness of your welding. And as Ramkesh told, just UW, if you refer that one. And also in PVA light, when you calculate or reports, if you find there, they mention the clause in that one also, UW, which UW they are using, and by using what thickness they are arriving with that one. So by referring that one also, you can find how this thickness is arrived fillet in that one.
Okay, and I understood the design thickness is the throat thickness. Okay, that is I guess 1.414 something we take or 1.7 of neck thickness.
0.7 of your leg.
neck thickness. Oh, points out of leg.
Leg.
Yeah, that is your throat thickness.
That is your throat. So actually your tension in the main part, it will act as a shear at the throat. So that's why you should check for the shear stress in the welds.
Okay.
Okay, you got.
Yeah, I got it. The last question I have.
Yeah.
In the regarding heat exchanger only,
Mm-hmm.
in the tube sheet welding,
Mm-hmm.
in the design, I've seen there are three types of strength weld: the full strength weld or partial strength weld. We check for the two cases. So I try to understand from the net also, but I'm not able to understand clearly. What are these two types of weld strength for which we check? Full strength and partial strength.
And in tube to tube sheet joint,
Correct.
Shell to tube sheet, right? Or tube to tube sheet?
No. It's tube to tube sheet.
I think recently Atul Sharma, till I think maybe he can.
You want to answer?
I think there's discussing in
Tube to tube sheet means if welding is available, we consider as a polyester.
Yeah.
If no welding, we consider as a no weld and a thin weld. Partially we could not take because we have to design it like a conservative side. So if there is any weld, we go with directly strength weld. And generally we provided J groove there from tube sheet.
If it is expanded, okay. If it is expanded and also welding is done. So can we tell?
Yeah,
it is a full strength weld.
also we can use a full strength. But our
no welding,
number,
but it is full expanded. In case it is not welded, but it is full expanded.
yeah, then it is a heavy expansion, na? Without weld.
Yeah, correct. Then also we can say it is a full strength.
Yeah, it is full strength expanded joint,
Full strength expanded.
but there is no welding.
Yeah, actually, Abhishek, just I want to add here.
Yeah.
Actually, this full strength, no, when we weld completely, and that whatever the margin will take in the calculation, no, for that one they consider it as a full strength. Means it's the welding between the tube and tube sheet. It's completely done thoroughly from both the side, inside and that is considered. But partially there are sometimes they are not weld complete, means outside. They partially they'll weld and they'll expansion joint they will keep without welding that tube. On that cases they will keep as a partially weld, right, Atul?
No, I think let me say my understanding. What is full strength weld in the sense? If I mean even if the tube fails, the weld should not fail. I think that is the condition. That is full strength.
Normally design we used to take full strength only because it should not fail, and even the expansion whatever the inside they done completely full double groove expansion or single groove expansion, still they will do the full strength weld only, and in calculation also we used to take full strength only.
Yeah, Ravi, what I'm saying is what is full strength means whatever the tension load the tube can take, it is full load. That much load this weld should bear. So that is full strength.
L test value.
Yeah, that is full strength.
So that is full strength, but in calculation, so normally how means you consider as a full strength only, no? Or you will consider partial?
Yeah, generally full strength weld.
Yeah, normally we consider full strength only in calculation. So partially will not go, and even client also says that partially if you go means the strength what is your welding, it's not that means fully it's withstand with that one, the loads what is coming on that one, like
Yeah,
that.
and this strength comes into picture when it is fixed tube sheet. So when it is U-tube or floating, it doesn't matter
Yeah.
because no load. So when it is U-tube or floating, it doesn't matter
Yeah.
because no load will come because it is tube is free to expand, so no differential thermal expansion. So there.
So yeah, it's they fixed. It's attached to the shell and that one. So on that
Yeah.
case, this comes, this picture comes. Okay, Abhishek, you got answer?
Yeah.
Okay.
And then who defines that it should be full strength or partial strength?
Yeah, that's
defines it?
what. See, as I told you, so as I told you, this will come only in the fixed tube sheet kind of configurations. So, how much load will come because of the thermal expansion? So, you should design at least for that. But for some clients, say no, you design for full. So, that's what.
This is normally decided by client. Client if says that if it is full strength, then we have to do the calculation. And normally he says that full strength only. And some clients say that okay, partially. Partially in that one, some of the parameter will changes. Maybe a small change in thickness or a change in this one, weld strength and that one, weld size and that one. So, but normally client says go for full strength only. So this is decided by the client only.
Yeah, and EIL has some guideline for where we have to use strength weld and where we have to use expanded joint.
Expanded joint is different and this full strength is different. Expanded joint is just they create the groove in that one and they will tighten with that one.
Now for expansion also, I think there is a strength criteria. Yes. So because expanded joints we use in fixed tube sheet also, so that should also whatever the pull coming because of the expansion, so it should be and so there also it is important. So I think maybe appendix A, I think it's maybe you can refer this.
Yeah, appendix A.
Yeah.
Okay, Abhishek, you got your answer?
Yeah, I got it. Yeah, thanks, sir.
Okay. Any more?
I have some question related to this.
Yeah, Antarji.
The past one is like appendix A. Now it is UW 20.4.
The UW no. UW 20 is for welded joints. And
But in it's a 223 code. I think some old formula appendix because it was last in non-measured appendix. Now it is 23.
Okay.
And there is a formula for FR value attached upon HT, AT, FY and FT.
So where it is, you are saying UW means UW.
Yeah, it is mentioned in it is this formula first was mentioned in appendix A. And now it is mentioned in UW 20.4.4 into the 23 code.
That is only for welded joints then.
Yeah, only for welded joint.
Yes.
But in as per ASME there is no requirement for expanded joint to do pull-out test.
Yes.
Yeah, but if a client specification have mentioned that you have to do pull-out test, tie a mock-up, and then now my FR value is coming less than the 0.9, then now what I have to do? Now my mock-up is failing. My FR value is coming 0.7. I can't do nothing. What can I do now?
Can you repeat the question again?
Yeah, my question is my tube joint is expanded with 2 groove.
Right. Correct.
As per ASME, there is no pull-out test required because this is expansion joint.
Okay.
Yeah.
But tax mention, you have to do mock-up and prove FR value greater than 0.9.
Okay.
But my FR value not coming 0.9, it is coming 0.7, 0.7, 0.7 for 3 specimens.
Okay.
Then I have to revise tube to tube sheet joint, go with welded, or there is any chances or any exceptions which I can take because it is client requirement.
No. I think it's for the expansion joint also it is there, I guess. 1 minute.
Yeah.
Okay, I need to refer the code, so maybe you can continue with other topics.
Yeah. Like I read all the clauses of the code. Code have no method to do with expansion joint. There is a criteria if SY upon SYT value is less than 0.6.
Okay.
Then you have to do for expanded joint. Otherwise shear load, shear test not required. But client specification have mentioned this you have to do. Now ASME supersede.
Okay.
So this is the client requirement, and this is the addition to codes. This is client requirement. So
the client requirement, but this requirement is conflict with the code, na?
the conflict means there are the priority which to be followed on it's they given the sequence of the document that means first is the codes, next is the client specification, next is your data sheet or like that.
No. What is Ravi? What here he is saying?
Mhm.
The full strength design is required as per the client specification.
Yeah.
So he is saying in the code it is given only for welded joints and not for expansion joint.
Yeah.
Yeah, absolutely.
So that he want to. I mean, there is nothing even in the code for the expansion joint. So he's saying now should I go back to the welded? I mean, you should change the type of joint.
Now they mailed me today. Their team is saying that we provide this geometry to the another vendor, but he passed.
Mhm.
So
No, that's what I think. There is something in the code. I remember for expansion joints also you can do it.
if the another vendor is passed, then just ask them that give that document, whatever the calculation, what he done. We will follow the same thing like that. You can ask them.
Yeah, because we did it in the lab, we did it proper testing in lab, and I think there is an issue with the two material.
Yeah, whatever may be, but if one can pass that one and they want to follow you with that vendor, so just ask them any contact number or something. Just check with them what they done and what is different you are doing. So follow the same thing, you will get passed.
Yeah, I contact with the lab, but my lab operator says that we can pass in anything in the paper.
Yeah, paper. That's I'm saying. Just check with that other vendor whether he actually just passed on the paper or actually he done in the lab. So if he just passed on the paper, then you also means if client is asking to do on the just paper, so it's not a correct way. So just inform him that.
Failing on only pull out condition. All is passed, hydro passed, and everything passed, pneumatic passed. Only pull out fail.
Mm-hmm. So you can discuss with that and you can show your lab report to your client. There is something wrong with your other vendor. Just check or re-verify or give the contact or details. Just check with them what they are doing and what you are doing. So you can match with.
Yeah, I'm regularly contact with them.
So just match with them or just correct where you are wrong or they are wrong. So you will be both making the same line. So that the client will be happy because you are getting both on the same things.
Yeah, because I back calculate the code.
Mm-hmm. So
and I found it that there is no any circumstances that then we have to do FR test.
But code again, the client specification oversits the code one. But if client says that I require this, because in code also said the final decision by the purchaser. So purchaser if says that I require 0.7, then you have to pass with 0.7 or 0.9, whatever he is asking.
Yeah.
So I think it is better way just to check with the other vendor what he is saying he is passing. So check how he is passing with that one. So if it feels it's well and good, you can follow. Else you inform to client this is the wrong what other vendor doing. Like that.
Yeah, absolutely.
Okay.
Okay.
Okay, Adosh, do you have any more issues?
No, I don't have anyone right now.
Okay.